The star is an enigma to scientists who are still studying its power and potential. As they investigate this magnificent star in depth, they have discovered something terrifying. Join us on this tour as we delve into the constellation Orion with the James Webb Telescope and explore how its arrival could change our understanding of the root of stellar evolution and its impact on the cosmos. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell to never miss an update. Although many people are unaware of this fact, it is possible to spot Betelgeuse, often mispronounced or stylized as Betelgeuse, in the night sky during the winter months in the northern hemisphere. Just look up at the sky and focus on the constellations Orion and Canis Major to see this dazzling star in all its splendor. There, you can easily locate the reddish-orange star that marks the upper left corner of the rectangular shape of the Orion constellation. The star is one of the largest and brightest in the night sky, making it difficult to miss. However, if you have looked closely at the star, you'll have noticed that it does not remain constant. In fact, it varies in brightness periodically. This peculiarity is no coincidence, since Betelgeuse, or Betelgeuse as the star is referred to here, is no ordinary star. Although to us it may appear to be just one more twinkling light in the vast firmament, it is located at a staggering distance of more than 640 light-years from us. At first glance, this figure may not seem impressive compared to intergalactic distances, but in reality, it represents an enormous chasm of space. To illustrate the magnitude of this distance, let's imagine that we could travel at the speed of light, which unfortunately is not possible with our current technology. Even in that hypothetical scenario, it would take us more than 640 years to reach Betelgeuse. If we wanted to undertake such a journey in a spacecraft, even using our most advanced propulsion technologies, it would take us more than 12 million years to reach it. This figure far exceeds the entire history of human civilization on Earth. However, the dimness of light we perceive from Betelgeuse is not solely due to the distance that separates us from it. Betelgeuse is what is known as a pulsating red supergiant, which means it is an ancient, massive star that undergoes regular cycles of expansion and contraction. During these cycles, its brightness can vary in the night sky, becoming more intense or dimmer. These brightness changes can occur over extended periods ranging from tens to hundreds of days. The amazing thing is that Betelgeuse can oscillate in brightness over a wide range. Its magnitude can range from near 0.5 to reaching 0 magnitude, making it extremely bright. These changes follow specific cycles, with the shortest being 185 days and the longest being 2,335 days. At certain times, Betelgeuse can become quite faint, a state referred to as van magnitude. In February 2021, it was reported to present its lowest van magnitude in a long time, reaching a magnitude of plus 1.614. Although this is still relatively bright, it is definitely fainter than how we usually observe Betelgeuse. However, brightness is not the only outstanding feature of this star. Betelgeuse is known for its distinctive reddish color, which is due to its cool surface. It has a surface temperature of about 3,500 Kelvin. This temperature is much lower than the surface of our Sun, which reaches approximately 5,500 Kelvin. This lower temperature means that Betelgeuse emits much less energy per unit area compared to the Sun. That is why, despite being one of the largest stars we know, it appears much dimmer to the naked eye. Betelgeuse is like that gentle giant who is satisfied with a low profile and doesn't need to show off its size to feel important. However, don't be fooled by its appearance. Betelgeuse is a true supergiant star, approximately 20 times the mass of our Sun. This is one of the key reasons why the star has been the subject of numerous studies over the centuries. It has been a prominent object in the night sky since antiquity and was first identified by the ancient Greek astronomer Ptolemy. Its name in Arabic means Orion's armpit, a nod to its location within the constellation. Although not much could be known about Betelgeuse at the time, modern telescopes have enabled researchers to study this phenomenon in far greater detail. By analyzing the light emitted by Betelgeuse, astronomers have been able to determine many of its properties such as its size, temperature, and composition. The Hubble Space Telescope, for example, has provided detailed images of Betelgeuse's surface, revealing intricate patterns of gas and dust. These observations have allowed researchers to create sophisticated models to understand the star's behavior and predict its future evolution. Betelgeuse has also been studied using the Atacama Large Submillimeter Array, or ALMA, a state-of-the-art observatory located in the high deserts of Chile. ALMA has provided high-resolution images of the surface of Betelgeuse, revealing details about its structure and dynamic behavior. One of the most remarkable discoveries made by ALMA is the presence of an extensive plume of gas extending outward from the star's surface. This plume is believed to be caused by the star's pulsations. These pulsations can be explained by a process called convection, which involves the rising of hot gas and the sinking of cooler gas. This motion creates waves that travel through the star's atmosphere, causing it to expand and contract. Thanks to the Hubble Space Telescope, detailed images of Betelgeuse's surface have also revealed similar plumes and disturbances, confirming the findings from ALMA. In addition, Betelgeuse's surface is marked by dark spots, also known as star spots or magnetic spots. These are areas on the star's surface that exhibit particularly strong magnetic intensity. These regions are cooler than their surroundings because the star's magnetic field inhibits the flow of gas from the interior to the surface, creating a cooling effect. As a result, the spots appear darker compared to the rest of the star. Betelgeuse's magnetic field is believed to be thousands of times stronger than that of the Sun. This intense magnetic field causes the gas on the surface of the star to be trapped in loops or arcs, describing regions of intense magnetic activity that are visible as star spots. It is important to mention that the presence of star spots is not unique to Betelgeuse. They are also observed in other stars, including our own Sunday. However, the star spots in Betelgeuse are especially interesting because of their size. They are several times larger than Earth and cover up to 20% of the star's surface, which is significantly larger and more numerous than the sunspots seen on the Sun. These star spots can affect the overall brightness of the star and cause variations as the spots move in and out of view. As Betelgeuse undergoes pulsations and the star expands and contracts, these spots rotate in and out of our line of sight, further amplifying the star's observed brightness variations. The surprising thing is that Betelgeuse is not as unique as one might think. While there are not many stars like it, there are some that share certain similarities and are equally fascinating. One of Betelgeuse's cosmic cousins is Antares, another red supergiant located in the constellation Scorpius. Antares is also a variable star, meaning that it undergoes changes in brightness over time just like Betelgeuse. In addition, Ants has a mass approximately 12 times that of the Sun and a radius that is 700 times that of the Sun. So it's safe to say that Ants shares both the grandeur and mystery of Betelgeuse. These similarities offer astronomers another point of comparison as they study the life cycles of massive stars. By comparing these stellar giants, researchers can improve their understanding of supernova precursors, mass loss processes, and the final evolutionary phases of stars much more massive than our Sun. In the end, stars like Betelgeuse and Antares offer more than just beauty in the night sky. They serve as celestial laboratories, massive furnaces where the elements are forged, light is sculpted, and the future of galaxies is written. With the James Webb Space Telescope and other modern observatories continuing to peer into these ancient beacons, we stand at the threshold of unprecedented insight into our universe's most powerful and mysterious giants. The study of Betelgeuse, Antares, and other red supergiants is not just a scientific curiosity. It plays a crucial role in unraveling some of the deepest mysteries about the cosmos. These stars are not only ancient and immense, but they are also the progenitors of some of the most cataclysmic events in the universe, supernovae. When a red supergiant like Betelgeuse nears the end of its life, it will no longer be able to sustain nuclear fusion in its core. Gravity will overcome the outward pressure produced by the fusion reactions, causing the core to collapse. In an instant, the implosion will trigger an enormous explosion, expelling the star's outer layers into space in a dazzling supernova event. Astronomers believe Betelgeuse is close to this evolutionary phase. In fact, much of the speculation surrounding this enigmatic Astronomers believe Betelgeuse is close to this evolutionary phase. In fact, much of the speculation surrounding this enigmatic star stems from the anticipation of its impending death. When Betelgeuse does eventually explode as a supernova, it will be one of the most visually spectacular celestial events witnessed by humanity. The explosion will be so bright that it could rival the full moon in luminosity and even be visible during daylight for several weeks. This event would not only be a remarkable sight but also an extraordinary opportunity for scientific observation, potentially answering long-standing questions about stellar death and rebirth. Despite the dramatic nature of a supernova, the Earth is at no risk from Betelgeuse's eventual explosion. At over 640 light-years away, the radiation released in such an event will dissipate significantly before reaching our planet. What we would observe would be light and neutrinos, harmless particles that travel across the cosmos unimpeded. Still, the scientific instruments on Earth and in space will be poised to collect an unprecedented amount of data, from gravitational waves to X-rays, offering new insights into core collapse mechanisms and neutron star formation, or even black hole birth, depending on the mass of the collapsing core. What makes Betelgeuse's case even more compelling is the ongoing mystery surrounding its irregular behavior. In late 2019 and early 2020, astronomers observed an unexpected dimming event where the star's brightness dropped to historically low levels. This great dimming sparked widespread theories ranging from dust clouds obscuring the star's light to structural changes in the star's outer layers. The James Webb Space Telescope and other observatories continue to monitor the star closely to determine if these fluctuations signal the prelude to its demise or are simply extreme episodes in its pulsation cycle. Moreover, the death of a star like Betelgeuse is not merely an ending, it marks a new beginning. Supernovae play a critical role in cosmic ecology. The explosion disperses heavy elements such as carbon, oxygen, and iron, materials essential for planet formation and life, into the surrounding interstellar medium. These elements enrich future generations of stars and planetary systems. In this way, Betelgeuse's final act will seed the galaxy with the building blocks of new worlds and possibly even life itself, millions of years from now. In myth and memory, stars like Betelgeuse have occupied a sacred place in human consciousness. From ancient Mesopotamian sky watchers to the telescopes of modern astrophysicists, this glowing giant has always inspired